In a previous video, we explored how humans learned to light and use fire. We learned that using fire allowed them to cook and extract more energy from their food while drastically reducing feeding time. The mastery of fire paved the way for countless innovations, propelling humanity from the Stone Age to the digital age. The blessing of fire comes, however, at a price. Humans, all humans, depend on external sources of energy. While this has been true for nearly a million years of hominid evolution, human energy demands have skyrocketed in the past centuries. As a species, we are now entirely reliant on external energy. Throughout prehistoric and historic times, the primary source of energy was the burning of wood and other organic materials, like the cow manure we see here being processed in India, which were at least partially renewable. In recent centuries, these sources no longer meet the demands of a growing humanity with an ever-increasing appetite for energy. As a result, humans began mining and burning fossil fuels in ever-growing quantities. In previous videos, we discussed the climate effects of burning fossil fuels and releasing CO2 into the atmosphere. If we continue to rely on this energy source, we are heading towards a climatic disaster. Moreover, apart from the effect on the climate, these fuels pollute the air and cause millions of premature deaths annually. The most significant innovation with the potential to make human energy consumption sustainable was the discovery of the electric power. Most electricity is produced by electromagnetic induction. Moving or rotating a magnet near a coil of wire induces an electric current in the wire. In power plants, electricity is produced by a turbine powered by some source of energy to rotate a shaft with a magnet inside the coils. Electric current produced in this manner is fed into the power lines all the way to our homes. We have been using electricity for over a century, yet most of it is still generated by burning coal, oil, and gas. In fact, electricity production remains the largest source of greenhouse gas emission and air pollution. Electric power can, however, be generated through methods that do not release such gases, that are renewable and vastly less polluting. Some, like nuclear and hydroelectric power, have been in use for many years, while others, such as photovoltaic, PV, solar panels, are more recent innovations. Renewables accounted for 30% of electric generation in 2023. These consist of hydro 47%, wind 26%, solar 18%, biomass 8%, and geothermal 1%. China is the largest producer of global renewable electricity, followed by the United States, Brazil, Canada, and India. Renewable investments reached about $500 billion globally in 2022. The renewable energy industry employs about 14 million people. Let us now briefly discuss some of the main sources of renewable energy. Humans have been harnessing the power of flowing water for millennia. This old water mill we filmed in southern France is a good example of traditional use of hydropower. The basics of electricity production we just learned is the turning of a shaft with a magnet inside coils of wires. It was thus straightforward to connect this shaft to a rotating water wheel. Indeed, about 15% of electricity worldwide is currently produced in this manner. This form of electricity production does not release carbon, does not cause air pollution, and is renewable. However, the installation of hydroelectric plants has in some cases significant environmental impacts. Hydroelectric plants are based on dams built to create upstream reservoirs to regulate water flow. These dams lead in some cases to flooding of huge areas and disrupt large rivers. Many of these reservoirs are used, like Lake Nasser created by the Aswan Dam on the Nile, to regulate water flow, to prevent seasonal flooding, and to ensure water supply during dry seasons. The hydroelectric plant of the Aswan Dam supplies a significant percentage of Egyptian electricity. We will discuss river management in a later part of the course. Innovative methods of producing electricity are further developed by harnessing waves and tides. I'm standing here in the harbor of Jaffa, next to an electricity generator powered by wave power. These blue things you see over there, they go up and down with the waves and are connected to an electricity generator on land,
and they can power about 100 homes at peak capacity.
Humans have used the power of wind since antiquity. Here we can see windmills in a painting from the Renaissance. The rotational force created by windmills could be easily adapted to turn an electricity generator. From humble beginnings, wind turbines now produce 8% of global electricity. Almost a third of electricity in Germany and the United Kingdom is produced by wind turbines. Wind energy prices have fallen by 70% in a decade and continue to fall, and are now, alongside PV solar panels, the most economical source of energy. Turbines do not emit greenhouse gases or pollutants, and they are exceedingly safe. Like all sources of energy, wind turbines also have downsides. A major environmental issue of wind turbines is that many migrating birds are hit by them. Migrating birds look down and not forward, as they do not expect any obstacles in front. Methods to reduce this mortality are being developed. Many wind turbines are now installed offshore, where they do not take up precious land and can harvest stronger winds. The most abundant source of renewable energy on Earth is the sun. The amount of solar energy that shines on Earth in 1 hour is equivalent to the entire human annual energy consumption. Solar energy is commonly converted to electricity in photovoltaic cells made of silicon, like the ones you see here. The sun's radiation that hits these panels induces an electric current in them. This method of producing electricity is different from its production by electromagnetic induction I described above and used by all other methods. In 2023, solar energy accounted for about 5% of electricity produced worldwide. However, harnessing solar energy is the fastest growing sector of renewable energy. In a decade, prices of its production have fallen by 90%. And are now, alongside wind turbines, the cheapest source of electricity. This progress has been achieved by innovation in the development and mass production of photovoltaic cells made of silicon. Efficiency of these panels now reaches about 25%. More efficient panels, panels made of other materials that are much cheaper, are under development. A major problem of solar energy is that it requires plenty of space. Possible solutions are mounting PV panels on roofs and other wasted space, mounting them above shade-loving crops on fields, and mounting them on water reservoirs, thereby also reducing evaporation. There are also large areas like this Arabian desert we are flying over that are flat, arid, and uninhabited and can be used. These areas have a lot of sun. However, they are often far from the places where energy might be required. Electricity is of course not the only way for using solar energy. I'm standing on the roof of my building, and you can see here these panels which are used for heating water. Almost all the water I'm using throughout the year is heated with these panels, and this is a well-established, pretty old technology which saves a lot of fossil fuel and is highly efficient. Another, almost limited renewable low carbon and safe source of energy lies right beneath our feet. The interior of our planet is extremely hot, and in many places, particularly in volcanically active regions, this heat reaches the surface or comes close to it. We are here in Iceland, one of the most volcanically active countries in the world. We can see hot water erupting in geysers. This geothermal water is used to heat almost all the houses in Iceland and to generate electricity. Globally, the use of geothermal energy still lags behind other renewable sources, but it is starting to play an important role in many countries. For example, nearly half of Kenya's electricity is generated from geothermal energy. Now we are on the volcano on the island of Sumatra, Indonesia, the second largest producer of geothermal energy, after the United States. The potential of this energy source is enormous, and the technology to harness it is both available and steadily advancing. About 9% of the world's electricity is produced by nuclear power stations. These stations generate energy through nuclear fission, the splitting of the nucleus of a heavy atom, such as uranium-235, into two smaller nuclei, releasing a large amount of energy. As in other power stations, this energy is used to produce steam that drives turbines to generate electricity. The uranium needed to fuel these reactors is a finite source, meaning that nuclear energy is not truly renewable. Moreover, there is serious concern about the radioactive waste products they generate. However, because nuclear power plants do not emit greenhouse gases, they have in recent years regained recognition as a crucial tool in the fight against climate change. Electric power plants, powered by fossil fuels, geothermal energy, and nuclear reactors, produce electricity continuously, 24/7. In contrast, solar energy varies both daily and seasonally, and is further affected by weather conditions, just like wind turbines. The seasonal availability of water can also impact some hydroelectric plants. Electricity demand itself fluctuates daily and seasonally. Therefore, the ability to store electricity is essential if you want to rely on renewable sources. The most basic method of storing electricity is by pumping water to a higher elevation and then releasing it to generate hydroelectric power when needed. Recent advances in battery technology now allow us to store electricity more efficiently and cost-effectively than ever before. Several innovative approaches to electricity storage are emerging. One promising idea involves the growing number of electric cars. Since most cars are stationary for much of the day, their batteries, when connected to the grid, can serve as a vast decentralized energy storage system. These batteries can power the owner's home or even feed electricity back to the grid. I would like to end this exciting and very brief review of the major forms of renewable energy with this plot prepared by Hannah Ritchie and Max Roser from Our World in Data. This chart compares the safety of different energy sources to their greenhouse gas emissions. Strikingly, coal and oil, the fossil fuels that emit the most greenhouse gases, are also the ones that cause the most lethal air pollution. Around 7 million people die prematurely every year due to air pollution, making it the leading environmental cause of death. So even if watching this entire chapter hasn't convinced you that greenhouse gases cause climate change, you might still reflect on the horrendous toll of air pollution and the enormous benefits of shifting to non-polluting energy sources that also happen to be low-carbon ones. We have seen that we have access to almost limitless amounts of safe, clean solar, wind, hydro and geothermal energy, as well as cost-effective and efficient technologies to harness them. Switching to these sources will not only benefit the climate and our health, it will also boost the economy.